Hi, everyone. In this set of lectures, we're going to cover computers and digital devices. We're covering much of the content from Module 2 of the textbook Computer Concepts from Parsons 2018 or earlier version 2016 is okay too. And this is the Module 2 on the textbook, which may not correspond to our module on our own site. We're going to be covering digital devices basics, computer types, processors and memory, storage, and input and output devices as well. Device basics. Here we're going to be talking about computers, circuits and chips, components, and maintenance of computers more broadly. Computer and digital devices. Computer is a multi-purpose device that accepts input, processes data, stores data, and produces output, all according to a series of stored instructions. By this definition, the old computers of the 1950s, such as this vacuum tube computer, may potentially be considered a computer still. But we usually talk about computers as those devices powered by microprocessors. Microprocessors, which processes the binary data. The microprocessor is the brain of the computer and the main processor, hence its name, of data in modern digital devices. There are various types of computers, and of course they have evolved over the years. The servers, all of these computers here in the server space of Google, these are Google computers, is our one kind of potentially called supercomputer, as they're all connected to each other, but don't really require, as you see, output devices such as screens and monitors, except for one that can control all of them. And of course, we have mobile handheld devices, cell phones, smartphones, we call them, which are actually just small computers, essentially. And we'll be discussing more of these in a future lecture. The microprocessor. The microprocessor may be the defining feature of any digital devices. And it is also called the microchip. And that one's also called the brain of the computer. And it uses arithmetic logic. So basic mathematical arithmetic, such as 2 + 2 = 4, and which of course can build to more complex mathematics, such as exponents, multiplication, and so on, and conditional logic, such as if something is one way, do this, if something is another way, do that. So it has the ability to process mathematical data, but also this kind of logical human conditional logic, in a way, via things like the logic gates, which are part of the hardware, logic gates. So it's on the top of the zeros and ones, the binary data, there are different kinds of hardware, and of course, more specifically, the microprocessor that needs to operate on that binary data by using arithmetic logic as well as conditional logic to direct decision-making and operations of the computer. All of the calculations and logic on how to move the documents, on how this person is moving from the left to right and underline this word here, which is drawing a graphic, actually, the processing of text, everything that is happening in the computer, the shining of the light on the screen is ultimately done by the microprocessor based on the logic and the manipulation of binary data. The microprocessor is also called the central processing unit, CPU, and you may be familiar with this term. So they're kind of used interchangeably. A microprocessor is also known as computer chip or microchip, and it's this one little device that usually we see, and you may see multiple of them in a larger system unit or a circuit board. Integrated circuit. An integrated circuit is a set of electronic circuits on one small flat piece of semiconductor material, normally silicon, a microchip. So a microchip or microprocessor is a kind of integrated circuit. Because it has within itself an entire integrated circuit, as you would see on a circuit board. Integrated circuits can be classified into analog, digital, and mixed signal, consisting of analog and digital signal on the same IC. And the main difference between analog is that the analog is usually based on the manipulation of the sound waves, the electrons essentially, but a more of waveform. And the digital is, it's actually still about wavelength. It's still about electricity, but it's kind of more the binary, it's 0 or 1. Digital integrated circuits can contain billions of logic gates, these little tiny, essentially chemical engraftment on the microchip, flip-flops, multiplexers, and other circuits in a few square millimeter. That's kind of tiny, it's smaller than this square here. So that's a microchip. And inside of it, you have all of these little electrical pathways and the transistors which store the binary data, and then the logic gates themselves. It's very, very tiny. It's microscopic. Erasable, programmable, read-only memory, EPROM integrated circuit is an example here in a dual inline packages. These packages have a transparent window that shows the die inside. The window is used to erase the memory by exposing the chip to ultraviolet light. So it's electronic and can be modified by electric signals. This is a Raspberry Pi. This is a motherboard or system board. And here is the microprocessor right here. So the central processing unit. As you can see, of course, it's connected within a circuit board that allows it to, for example, connect to the internet. So here, Ethernet, there's an Ethernet entrance. So if you need to connect to the internet, you may need to plug in a cable here that connects to other computers on the internet. So the microprocessor by itself is like a brain without a body. It needs a body within which to send its signals and from which to receive. So this may actually be a display, for example, a display card. So the microprocessor needs to get information from, usually send that out, right? To display, it's an output device. So from it to an output and so on. And there are various other kind of processing that happens here. I think this is also a microprocessor, microchip. And within it, there's like a motherboard like this inside of it, an integrated circuit. These are also other ports for our connections. We'll talk more about this later. Circuits and chips. The little circuit is composed of the microcircuit, the microchip, electrical pathways, so the lines, and the lines carry a little shot of electricity. Transistors, the circles, and which store or change the zeros and ones. So the transistors are what stores the binary data. Just really a little piece of semiconductor chemical. And resistors, rectangle used to adjust electric signal. So these pieces here to moderate the signal to make sure it kind of sends the right signal, the 0 or 1 as needed. The electronics for digital devices require millions of these circuits and transistors. Today, the circuitry is condensed into microprocessor. Microchips are usually made out of semiconductor material. So like silicon and germanium, which have properties of a conductor like copper, which can conduce electricity, allows electricity to move through it, and an insulator like wood, which stops electricity from going through. This enables the electric signals to be coordinated and manipulated to precisely modify just zeros and ones as it needs to create the computer operations and functions, like to add and subtract and move around data. Here's an example from the book of how the chips are created. You have a blank semiconductor chip, so just kind of a blank of the material with that kind of chemical. And then the circuits are actually etched. This is the word I was looking for before. I don't know what word I used, but etched onto it. So it's really a chemical process. And then, of course, there are other little more material physical devices that need to be implemented within the microchip itself. And you can see the size. This is a real human nail. So they are tiny, tiny, tiny. This is actually another whole system board for the Raspberry Pi, which is a tiny little computer that you can essentially put on your palm of your hand and carry it around. But of course, once again, a brain without a body. But here, a lot of the labeled parts of it. You can take a look at it later. Here, just another system board, another motherboard. And I kind of wanted to illustrate how it's interesting to think about this in relation to a real physical big factory, like an oil refinery, and the similarities. We kind of reduce the gigantic oil refinery into a little tiny chip that can fit on the palm of our hands. It's kind of amazing. Input and output. At every level within the microchip itself, but also within the motherboard broadly, and at the human interface level, the level of our fingers and eyes, there are mechanisms for input and output of data. Microchips contain their own input and output pathways within their integrated circuit. Motherboard is a board of input and output devices, as we saw, processed by the microchip with interfaces for digital devices and for connecting to the Ethernet, or through the Ethernet to the internet. A computer console and interface are the input and output components for interaction with human behavior, so keyboards and digital screens and so on. Human interface components of a desktop, we have cameras, displays. You must be familiar with this if you're taking this course and engaging with the material. We call these the input and output devices or interfacing devices. A laptop slightly different, but generally kind of the same features available, the same input-output devices. And of course, we have mobile, handheld, also smartphones, and still a computer, still a lot of the, so the keyboard, the input device changed to the screen itself. So we have a touch screen, which is both input and output, right? The touch screen. So that's important to note. Maintenance. Here are just some few messages about maintenance. So basic system unit maintenance, that is computer maintenance in general, is simple. Keep the unit clean from dust, prevent it from overheating, shield it from damage, and protect it from electrical surges. Dust, that is, remove the dust with a clean microfiber cloth, usually dry, and disinfect with appropriate cleaning wipes. If you're going to use some chemical, make sure it's appropriate. Use a low vacuum setting to remove dust from fan vents. This is kind of important too. People don't realize computers are physical devices. And the fans are there because it does get hot and it needs to blow out the air so it cools down. And then dust accumulates and so on. Use a protective case or carrying bags. It's always good to make your units last longer. Only plug into a surge protected, use surge protection. Make sure fans are functioning and protected from overheat. It's very important. Do not use any cleaning products without manufacturer recommendation. Never immerse a device in liquid or any sort. Usually digital devices are not going to do well with water. Do not allow cleaning agents or liquids to drip on keyboards or touchpads. Do not spray even appropriate cleaning agents directly on the device. Spray them onto a cleaning cloth first, the ones that you do want to use. Something about batteries. So most of today's battery-powered digital devices contain a lithium-ion battery. Lithium-ion batteries can overheat, and in the worst case, they can explode. So this is kind of an issue with batteries. That's why they ask you at the post office, go to the USPS, they're like, do you have batteries? This could be dangerous, but obviously a bigger battery, bigger potential risk than a smaller battery. Do not operate devices that are too hot to the touch. Some other list of maintenance tips. Turn off battery-powered device when not in use. This is a good idea. Charge before the battery runs out. And I actually kind of double-checked on this, and it really is. So I think for lithium-ion rechargeable batteries, this ensures longevity. That is, you do want to charge before the batteries run out, like your general smartphones, other laptops. Their likelihood is they are using lithium-ion batteries, rechargeable batteries. So it is good to not let the battery run out completely before you recharge it, but you might want to do that do discharging for at least once a month to do some resetting of the battery. So that's pretty much I think the most reliable information on this one I was able to gather. If your device becomes hot while in use, close most functions or off completely, disable unused apps that constantly connect to the internet. There are many of them. Many of the applications on your computer are connected to the internet, whether you know it or not, or even the communication itself can be turned off. So you can switch to airplane mode or shut off the Bluetooth or Wi-Fi, 5G. This saves on battery, saves on processing. You can reduce overheating, and may have other benefits for you as well. That's it for this one, and I'll see you next time.